Hello everyone. In this video, I'm going to introduce our project, which is called the NYC Crash Predictor. The main question we're trying to answer is, given a New York City zip code and 1 hour time block, how likely is that at least one motor vehicle crash will happen? So instead of just asking, will a crash happen or not, we're asking a probability question. We want to estimate the chances of a crash based on a location, time, past data, and uncertainty. To get a better idea of what I'm talking about, let's do an example. So here we have a zip code, time, and weather. We're gonna be assessing our probability based on this information. And the question we're trying to answer is, what is the probability at least one crash will happen? So this is the question we're trying to answer. We're not looking at an NYC crashes in general. We're narrowing it down to one place. This makes the prediction more useful, but also more complex because this is not a question with a guaranteed yes or no answer. We cannot say for sure a crash will happen or not. Real life is uncertain. Traffic, weather, driver behavior, and available data can all change. So our goal is not to predict the future perfectly. Our goal is to estimate a risk in a reasonable way. This is why this is a good problem for Monte Carlo simulation. Monte Carlo simulation is a method where we use repeated random trials to estimate the probability of an outcome. Instead of trying to predict one exact result, we simulate many possible versions of the same situation and look at what happens on average. In this project, the situation is a specific zip code during a specific hour under certain weather condition. Then we simulate that situation many times. This connects to an important idea in probability called the law of large number. The law of the large number says that when we repeat a random experiment many times, the average result becomes more stable and gets closer to the true expected value. So in our project, one simulation by itself does not tell us much, but thousands of simulation can give us a more useful probability estimate. This is the main reason Monte Carlo works so well for this kind of problem. We also have to talk about Poisson distribution, which is basically a way to count events in a fixed time. For example, it can be used for things like how many customers enter a store, or in our case, how many crashes happen in 1 hour. So let's look at this example for a time frame. In this time frame, we can have zero crashes, or one crash, or even two or more. But because we are mainly interested in whether at least one crash happens, we can later turn those simulated counts into a crash probability. The goal of this project is not to predict the future perfectly. That would be unrealistic. We cannot know exactly what will happen in one specific hour. Instead, the goal is to build a practical probability model that help us understand risk. In the rest of this video series, we will show how we clean the NYC crash data, build the Monte Carlo simulation in Python, validate the result, and create visualizations like charts and maps. Hope you enjoyed that. Bye.